Okay, so from today's lecture, we'll start with rotational mechanics. That means the code of rotational mechanics. I just gave you the basics in work energy theorem. Just look up the end questions of work energy theorem. Okay, and before we start today's lecture, I want to say something, or I want to have few minutes. I'll just take 2-3 minutes of your time. Okay, the first thing, the dates of JEE mains examination is already out. Okay, you can check in your city from the website. The dates are 22, 23, 24, 28, and 29. Okay, and shift 2 is around, means shift 2 will be from 30. Okay, and in these 5 days there will be 2 sessions. Morning session is from 9 to 12 and evening session is from 3 to 6. Okay, and the registration for session 2, that means the April attempt, will start from 31st January to 24th February. Registration for second attempt. Okay, 31st January to 24th February. You get around 1 month of time. Okay, see, few basic things I have to talk about. Okay, see, up till now we have done some amount of test series, this, all that. By now we have kind of perfected your exam temperament kind of thing. So what works for you? How do you approach the question? This kind of thing. The issue that I want to address out here is nothing but the exam stress or exam frustration kind of thing. See, I'll begin with a fact. Okay, stress or frustration will decrease your spatial memory. Okay, by now when you attempt some question, okay, if you have done a lot of test series, when you attempt some question, do you see that you see a question, you automatically come up with the formula and or the process, and just by finding out means you get to the answer. What I'm trying to say is, when you first read the question, you do not directly know what to do in the question. You just browse around the question and you ultimately find out the answer by whatever process you know, by whatever formulas you know, whatever things. Okay, so those kind of things are spatial memory. The point is I'm making out is, the more frustration you get or the more stress you take, that will affect your spatial memory, and you will perform much lesser if you attempt these questions or if you attempt this exam with a lot of stress or frustration. Okay, see, IIT is not the end of life and IIT is not the everything of life. What I mean to say is, if you have made consistent, dedicated effort, okay, disciplined effort, okay, regardless of you entering into IIT or not, you'll make somewhere in life. You'll get to somewhere. Okay, that is without any doubt. That should be without any doubt. And even by luck, okay, if you make into IIT without any consistent effort, you won't get that far. Okay, so disciplined effort are permanent in life. Okay, IIT is not a one-time ticket to some heaven kind of thing. Okay, so treat this exam as an important exam, but not ultimately everything that is happening in your life. Okay, understood? Okay, you'll end up, see, if you have the habit of making disciplined effort, you'll end up better places. You'll end up at better places. Okay, just don't make this exam about everything, means everything about this exam. Understood? Just practice a lot, go and give the exam, and have the courage to accept the outcome, whatever it may be. You might get selected, prepare for the next phase. Okay, if you get rejected, cry for a day. Okay, but that should be it. Next day, start for the next phase. Okay, start preparing ahead. Understood? Don't get stuck at one point, or don't constrict everything at IIT kind of thing. Okay, and I'll tell you a story about one of my teacher. Means he was his name is Asusho Shisharia. Okay, he used to teach us maths. Okay, he used to tell a term called bhannat kind of thing. Okay, and I used to make fun of him. Bhannat, this means whatever used to happen, bhannat. So one day he told us about his life story kind of thing. So bhannat is basically a Hindi term in his language. Okay, I'll try to explain what he told us inside the class. Bhannat is basically attitude. It's not attitude that I care less or I don't care about anything or I don't care about IIT. It's basically the attitude that whatever comes, I'll accept it. Or whatever happens, I'll deal with it. That's the attitude of bhannat. Okay. So take that kind of attitude to your life. It's not I do not care or I do not care about IIT, I'll leave studying, I don't want to study, nothing of that sort. Or I'll prepare for next exam, this exam is already wasted, nothing of that sort. It's I'll make my effort and whatever the outcome comes, I'll just accept it. Okay. I'll deal with my results. I'll make my efforts and I'll deal with my results. I have the guts to deal with my results. And that's what matters in life. Okay. So having said that, let's continue with our question. Okay, and all the best. So let's start with the question. Okay. In this question, there is a state law. Okay. There are two forces acting on this rod, F2 and F1. And the forces are separated by distance A. The value of F2 is given, the mass of the rod is given, and the rod is moving in a straight line, okay, without any rotation. Okay, we need to find out the length of the rod. One thing that I need to say about rotational mechanics is that, see, the problems in rotational mechanics have the same approach as linear mechanics. That means in Newton's law of motion, what you used to do is to construct equation using the theorem net force in any direction. Okay, or net force in x-axis is equals to mass into acceleration in x-axis, isn't it? And net force in y-axis is equals to mass into acceleration in y-axis. Or net tangential force is equals to mass into tangential acceleration. Or net centripetal force is equals to mass into centripetal acceleration. So is to find out equation or is to write down all the equation using this theorem and solve out the equation. Okay. In rotational mechanics, you do have to use this equation. The net force in any direction is equals to mass into acceleration. However, you also have to use an additional information or additional equation. That is nothing but net torque in any direction is equals to moment of inertia into angular acceleration in that direction. Okay. So in linear mechanics, you used to use only one term. In rotational mechanics, you have to use two terms. Now let's follow up with the question. Okay. See, two forces or two opposing forces are applied in this manner. Okay. Two opposing forces are applied. The rod will only move in a straight line. That means this force or the force F2 is greater than F1. Then only the acceleration in this direction will happen. Okay. And the acceleration is given as 2 meters per second square. If the linear acceleration of this body is given, that means the acceleration of center of mass of the body is given. Fair and fine. So the acceleration of center of mass of this rod is nothing but 2 meters per second square. The mass of the rod is given as 1 kg. The value of F2 is given as 5 Newton. Okay, we need to find out the length of the rod. The value of length A is given as 20 centimeter or 0.2 meter. Okay. Now we know that the center of mass of this rod lies below F2. And how do I know that? See, apply some amount of common sense. Two opposing forces. Okay, two opposing forces, if they lie or if F2 is even 1 millimeter below F1, okay, then the rod would tend to rotate. No, see, suppose this is the center of the rod. If I apply F1 in this direction, okay, my F2 has to be applied on the top part of the rod. No, then only it can move in a straight line, or then only it can oppose the rod, isn't it? If my F2 that is in the opposing direction, okay, suppose my F1 is in this direction, if F2 that is in the opposing direction happens anywhere below the bottom half or anywhere in this half, the rod is bound to rotate. The rod will only keep moving in a straight line when F2 or this force, okay, happens in this direction and F1 happens in this direction. That means both the forces are on the same part of the rod, okay, or same half of the rod. Understood this much? And we need to find out the length of the rod. So let us assume this distance to be x. Okay. Now let us consider or construct our equation. See, F2 minus F1 is equals to mass of this rod into linear acceleration of this rod. Okay. F2 minus F1 is equals to mass into linear acceleration. F2 is already given as 5 Newton. F1 we don't know. Mass is given as 1 kg. Linear acceleration is given as 2 meters per second square. Or from this equation, we know that F1 is equals to 3 Newton. Okay. So F2 is equals to 5 Newton. F1 is equals to 3 Newton. Now how do I find out the length? See, by using torque equation, okay, you can also find out the length. See, how do we apply torque equation? Consider any point, okay. For our convenience, we'll use the center of rod as the axis. Okay, if this is the rod, the center, okay, the axis passes through the center. Understood? So if the axis passes through the center, okay, at this point, this is my axis in this direction. What is the torque due to F1? Torque due to F1 is nothing but R cross F, and the torque happens in this direction. Okay, so this direction is F1 torque, and R or X cross F2. That means the torque due to F2 happens in this direction. So if this direction or positive Z direction is positive, then this direction would be negative Z. Okay, and torque are axial vectors. So F1. So let's write out torque equation. F1 into L by 2. That means if the length of the entire rod is L, this much distance is nothing but L by 2, or from center of the rod to point A. So F1 into L by 2 minus F2 into what is this much length? What is the distance x? Or minus F2 into x is equals to moment of inertia of the rod into angular acceleration of the rod. And since in this question it is already given move in a straight line, that means the angular acceleration of the rod is equals to 0, isn't it? The value of F1 is nothing but 5. Sorry, the value of F1 is nothing but 3. Okay, we have found out here. The value of F2 is nothing but 5, that is given in the question. Okay, so F1 is equals to 3 Newton, F2 is equals to 5 Newton. And we have to find out the value of L. Okay, so 3L by 2 minus 5x is equals to how much? 0. Or 3L by 2 minus 5x or is equals to 5x. I just put this 5x to the right hand side. Now x can be written as L by 2 minus a. This x can be written as L by 2 minus a. Or this entire length minus a. is nothing but this much x. Okay, so let me rewrite the equation. 3 into L by 2 is equals to 5 into L by 2 minus a. The value of a is given as 20 centimeter or 0.2 meter. So 0.2. Now when I solve this equation, let's solve this equation a little bit fast. Okay, 3L is equals to 10 into L by 2 minus 0.2. If I solve this one, okay, 2. L minus 2 into 2 is nothing but 0.4. So this is nothing but L minus 0.4 divided by 2. Okay, 2 and it will get cancelled to be 5. So this 2, this 2, this 2. Okay, 5 into L minus 0.4. It will be 5 into L minus 0.4. I'll get my equation something like 3L is equals to 5L minus 5 into 0.4 is nothing but 2. 5 4s are 20 and divided by 10 is nothing but 2. And if I send this 2, or 2 is equals to 5L minus 3L, which is nothing but 2L, or L is equals to 1 meter. So the length of this entire rod is nothing but 1 meter. Understood the question? This is a simple question. The main underlying point of this question is nothing but in your rotational dynamics or in your rotational mechanics, whenever you have this equation, okay, you must take the fundamentals of net force in a specific direction is equals to mass into acceleration in a specific direction, plus one more equation you have to use, that is net torque in a specific direction is equals to moment of inertia of the body into angular acceleration in that specific direction. Okay, understood? These are the two fundamental equations that you must be using. That's it. And that would be the basis of entire rotational dynamics. Okay, this is the fundamental way of solving entire rotational dynamics. Now this case is this question is a simple case of vector multiplication. Okay, there are two forces out here. Force of AI plus Bj and the radial vector small ai plus small bj. We have to find out the moment or torque about origin. Okay, so what this question is actually saying is that this is the Cartesian coordinate. Okay, this is the origin out here. At a certain point, a force is applied, F, and the magnitude of this force or the vector form of this force is given by this parameter ai plus bj. Okay, and the radius vector of this point, from the origin is given by r vector, and r vector is given by this ai plus bj. What is the torque about origin? So you already know from previous lectures, torque is equals to r cross f, isn't it? And you can either multiply by using determinants or you can simply multiply. See, if I use the determinant method, r cross f, you can use I, j, k. Okay, the first vector is r, so r will be written out here. R is nothing but ai plus bj, ai bj 0k. And the second vector f, is nothing but capital AI plus capital Bj. So capital AI plus capital Bj and 0k. Now when you solve these vectors, plus minus plus, okay, you will get something like r cross f is equals to how much? K into small a capital B minus small b capital A into k. Okay, or you can directly multiply. Directly multiply means r cross f, or torque is equals to r cross f, or r is nothing but ai plus bj, and force is nothing but a capital AI plus capital Bj, or capital AI plus capital Bj. Now in order to directly multiply, you just need to remember I cross j gives us k. Okay, k cross I gives us j, and if you go counterclockwise, k cross j gives us negative I. Okay, I cross k gives us negative j, and so on. Just need to remember this one. Okay, now see, small a into capital A is nothing but a into I vector into I vector. I vector cross I vector is nothing but 0. Then ai into bj, okay, is nothing but a into b. I cap cross j cap is nothing but I cross j cap is nothing but k cap. Now take this parameter b. See, if it was multiplied a plus b cross c into d, it would be ab plus this into this parameter plus this into this parameter plus this into this parameter. We're doing the same thing out here. Okay, this into this is equals to 0. Why? I cross I is equals to 0. This into this is a into b cross I cross j, and I cross j is nothing but k, plus bj into ai, b into a. So plus bj into ai is nothing but b into a. J cross I, I'm going anti-clockwise, is nothing but negative k, or negative k, and bj into capital bj. J cross j is nothing but 0. So leave it as it is. So torque is equals to ab minus ba into k. These are the same answer. Both are the same answer. It doesn't matter. It doesn't matter which method you use. Okay. So you got our torque or moment about origin. Okay. Now the next part of the question is asking us find the arm length L. Okay, length of arm L. Now my main focus out here is, or the main question that I have is, what is the arm length L? Okay, arm length L is nothing but the perpendicular distance from the force. What do I mean? See, whenever I say torque is equals to R cross F, so whenever you're doing like that, okay, you can do torque or radius vector into force into sine theta. Okay, torque is equals to R cross F, or R magnitude of R into magnitude of F into sine theta. Now I can say you can either take the component of F perpendicular to R or take the component of R perpendicular to F. Okay, so arm length L is nothing but component of R perpendicular to F. So this is the line F. Okay, now I have to take the component of this R perpendicular to the force vector F. So whenever I do that, a line will come, isn't it? Component of R perpendicular to F is nothing but this line, and this line is nothing but arm length L. Okay, understood? And to find out the magnitude of R vector, we simply use this formula. Magnitude of torque is equals to magnitude of R vector into magnitude of F vector into sine theta. Now see, if I use R perpendicular, can I say torque is equals to R perpendicular into F into sine 90? Because when I'm doing this perpendicular into F, the angle between R perpendicular and F is already 90. So out it will be sine 90. We already know the value of torque. The value of torque is nothing but this value. So AB minus BAK is equals to magnitude of R. What is the magnitude of R? Acha, we have to find out the magnitude of R. Okay, we have to find out this magnitude. That means this is asked in the question. This is nothing but the arm length. Okay, magnitude of R perpendicular into magnitude of force. What is the magnitude of force? Magnitude of force is nothing but under root of A square plus B square, isn't it? Into sine 90. The value of sine 90 is already 1. So R perpendicular would be nothing but AB minus BA, and we have to take the magnitude of this vector divided by under root of A square plus B square. Okay, this is the magnitude of arm length L. Understood this one? We simply use the concept out here. Okay, even this question is of vector cross product. Okay, so in this question, let this be x-axis. Okay, this is nothing but x-axis, this is nothing but y-axis, and perpendicular to x and y is nothing but z-axis. Z-axis is towards yourself. Okay, if I use my right hand, I'm saying again and again, since the screen is mirrored, you might perceive this as my left hand. No, the screen is actually mirrored. Okay, this is actually my right hand. I eat with this hand. Okay, so x, if I use my 3-finger rule, x, y, and z. Okay, so the z is in this direction. Now what the question is saying is that in the x-axis there is a point a comma 0. Okay, and at this point a force vector is acting in y direction with magnitude aj. Force is equals to aj. Okay, there is another point in the y-axis that is nothing but 0 comma b, 0 comma b, and a force is acting in x direction at this point. Force is equals to bi. We have to calculate the net moment about origin, or net torque about origin. Okay, so net torque about origin is nothing but torque due to this force plus torque due to this force. If you notice out here, the torque due to this force, or force on y-axis, the torque due to this force is nothing but towards this direction, or negative z direction, whereas the torque due to this force, or force on x-axis, this one, is on positive z direction. Okay, the torque due to y-axis, the torque due to force on y-axis is in negative z direction. Okay, whereas the torque due to force on x-axis is in positive direction. So this torque and this torque would cancel out each other. Understood? Just rotate your hand in the direction of force, that will give you the direction of torque. Torque, mostly all of your rotational variables are axial vectors. Okay, so you have to use your right hand. Now you might have a confusion about this method or this method or this method or screw rule. Okay, you can apply all the methods as long as you use your right hand, everything is correct. Okay, the simple fundamental rule to memorize is just use your right hand. Everything will be correct. Understood? No concept of left hand. Cut your left hand and throw it away. You do not need your left hand in your entire physics. Okay, so torque due to this force is nothing but R cross B. R is nothing but BJ. BJ cross how much? BI cross BI. Okay, this is minus. And this torque is nothing but AI cross AJ. AI cross AJ. Okay, I can simply use IJK. Okay, So torque is equals to minus d, the minus small b into capital B is nothing but bb. J cross I, j cross I, j cross I is nothing but minus k plus a. I cross j, I cross j is nothing but k. So if I do it like this, torque is equals to bbk plus a k. This is the simple question. Or torque is equals to bbk. So one more thing, I shouldn't have taken minus out here. I shouldn't have taken minus out here. Why? See, because the cross product is already giving us the direction of the torque. There is no need to include a minus out here. This is the error that I made. See, minus, I take my minus, or I add it, means I take the external minus, okay, when I'm just calculating with the magnitude and I have to sense the direction by common sense. But out here, j cross I is already giving us the direction of k cap, no? So j cross I will already be giving us the direction of k cap, so there is no need to include any additional minus out here. Understood? So minus this one, a minus b capital K. Okay, a minus b capital K. This is the value of torque. Now the value of next question. Find the arm length of the resultant force relative to point O. This question, or this part of the question, is same as previous part of the question. Okay, because if you add this force and this force, there will be a resultant force, isn't it? Resultant force, and that resultant force will pass through somewhere. Fair and fine. Okay. Now resultant force or total force is nothing but bi plus aj. Okay, you already know the value of torque. That means this resultant force creates this torque. So if I apply torque is equals to magnitude of arm length into magnitude of force into sine theta or sine 90, because arm length is already perpendicular to the force vector. Okay, so torque vector is nothing but a minus b k. You have to take the magnitude, is equals to magnitude of perpendicular arm length into magnitude of force. What is the magnitude of force? The magnitude of total force is nothing but b square plus a square under root into b square plus a square under root into sine 90. So r perpendicular would be nothing but a minus b k cap. Magnitude of that one is nothing but simply this variable, because this is a vector in one direction or in one axis. Okay, divided by how much? A square plus b square under root. So this is our answer for arm length, and this is our net torque. Okay. Now in this question, this is a square plate. Okay, and there are three forces applied out here. Okay. First, let us break down, or let us analyze this force. Okay, this F root 2 is nothing but a combination of force F and F. That means if I add two force in this direction and in this direction, I'll get a resultant of F root 2 in this direction, isn't it? Okay, so there are four forces applied out here. Now, what is the net force in x direction? Okay, net force in x direction is equals to this F plus this F, which is equals to 2F. What is the net force in y direction? Net force in y direction is equals to F minus F, which is equals to 0. So what is the resultant force? F net force is equals to nothing but 2F in y direction, sorry, in x direction. Okay, the resultant of all these forces is nothing but 2F in x direction. Fair and fine. Now if you look at the diagram, you can simply see that this plate is bound to rotate, no? Why? Because the forces are applied at different points, isn't it? So this plate is bound to rotate. This plate will rotate somewhere. And this plate will also accelerate, but I'm not taking the acceleration into account right now. Okay, I'm not worried about the acceleration. Let the acceleration be there. This plate will rotate, or this plate will rotate. Okay. The question is asking, find out the point in this line BC. Okay. This is the rectangular plate. Okay. This is BC. Find out a point in BC such that when this 2F is applied on that point, suppose a 2F is applied on this point on BC, this torque, the torque due to this 2F would be same as the torque due to these resultant forces, or torque due to this all the forces. Okay, find a point in BC where the resultant force is applied such that the torque due to this 2F on point BC on this point is equals to torque due to combination of all these forces. Fair and fine. Now to find out torque, we must consider our origin. Okay, you can take the origin at any point. Okay, This is just a method of calculation. You can take the origin out here, you can take the origin at center, you can take the origin out here, you can take the origin out. Okay. Let us just take the origin at the center of the square plate. This is the origin out here. Okay. This is my origin. This is my origin. So my question becomes, find the torque or find the point in BC where the 2F produces the same torque about this origin as this combination of forces. Okay. Now first thing is, what is the length of diagonal? The length of diagonal is nothing but, if all the sides are of length L, square plate. Okay. Length of diagonal is nothing but L root 2, or L square plus L square under root is nothing but L root 2. Okay. And this diagonal is also L root 2. Fair and fine. Okay. So if the total length of diagonal is L root 2, what is half of diagonal? L root 2 divided by 2. L root 2 divided by 2, which is nothing but L by root 2. So half of this diagonal is nothing but L by root 2. This is half the diagonal of a square. Okay. Now see. Now the first part of the question, let us find out the torque about center due to all these forces. This force is clockwise, this force is clockwise, this force is anti-clockwise, and this force or torque to this force is 0. Okay. Why? Because this force is directly, the angle between r vector and force vector is 0 out here for this force. Okay. So torque due to this force is nothing but this length into force. So net torque is equals to this length. This length is nothing but L by root 2, isn't it? L by root 2. Due to symmetry, this is also L by root 2, this is also L by root 2. So L by root 2 into F. This force is also clockwise, so it is L by root 2 into F plus L by root 2 into F. This force is anti-clockwise or counterclockwise, so it is minus L by root 2 into F minus L by root 2 into F, and the torque due to this force is 0 because angle between r vector and F vector is 0, isn't it? So net torque, total torque is equals to this, and this will get cancelled, L by root 2 into F. Okay, this is the total torque acting to the origin on this square plate. Now let's say the total force 2F is applied at this point. Okay, let this point be X. Okay, what must be this point X such that the torque due to this 2F about the center is same as this torque, isn't it? So let's find out the torque out here. Torque is nothing but, instead of taking from the top, I'll take from the bottom. Okay, I'll take from this position X. Okay, so torque due to 2F is nothing but 2F or this length, okay, or component of X perpendicular to 2F. Okay, this length into 2F. Now what is the component of X perpendicular to 2F? Is the component of X along this line, no? So this angle is 45. This angle should also be 45 because this is a square plate. The angle between two sides are 90. If I cut a diagonal from half, this angle is 45, this angle is 45. So if this angle is 45, these two are parallel lines. So this angle is also 45, this angle is also 45. So I can say X cos 45 or X cos 45. X cos 45 into 2F. This is the net torque due to 2F. And the question is saying this torque and this torque are equal. So I can say X cos 45 into 2F is equals to L by root 2 into F. So F and F would get cancelled. What is the value of cos 45? 1 by root 2 into 2 is equals to L by root 2, or root 2 and root 2 would get cancelled, or X is equals to L by 2. That means this 2F or this 2F force is applied at the midpoint between B and C. So distance between this X is nothing but L by 2, L by 2. Understood? This distance is nothing but L by 2. This was our entirety of the question. Okay. And one more thing, sir, should I only apply my torque about origin? No, you can apply through any point. Okay, the answer will come out to be L by root 2. Okay, it has the same answer. Now this question is about moment of inertia. Okay, moment of inertia is nothing but m into r square. But let me just say something about moment of inertia. Okay, moment of inertia. Moment of inertia. Moment of inertia is nothing but the equivalent of mass in rotational dynamics. Okay, in linear mechanics we used to use mass. In rotational mechanics we'll use moment of inertia. Okay, so let's say in linear mechanics we used to use something like force is equals to mass into acceleration, isn't it? Out here, torque would be equals to moment of inertia into angular acceleration. Understood? This much is it. The relation between moment of inertia and linear mechanics is nothing but moment of inertia is equals to m into r square. Fair and fine. Now one more thing that you have to note out here, okay, that is not precisely taught to you all is that, see, suppose this is my y-axis, this is my x-axis. Okay, I have any body, and suppose a force is applied out here in any random direction. Okay, there is a small body of mass m. The position vector of this is nothing but r. Okay. Moment of inertia due to this force, sorry, not moment, torque due to this force will be defined by a axis or from a point. Torque, angular momentum, all these values are defined from a point, you know. Okay, all these values are defined from a point, isn't it? So out here, net torque is equals to r cross or r vector cross a vector, isn't it? How do we break out the torque vector out here, or how do we break out this equation? Okay, this equation. How do we break out this equation? The alignment is a little bit off. Okay, see, in linear mechanics, you can do it simply like this, you know. Force in x direction. That means this formula can be written as force in x direction is equals to mass into acceleration in x direction. Force in y direction can be written as mass into acceleration in y direction, and force in z direction can be written as mass into acceleration in z direction, isn't it? This formula can be written as this three entity, or a combination of these three entity becomes this formula, isn't it? Similarly, out here, same thing happens out here. What I'm trying to say is torque and angular acceleration are axial vectors, isn't it? So if I want to find out the net torque about this point, torque in x-axis, okay, torque in x-axis means in this direction. And remember, torque are axial vectors. Okay, do not mean torque in this direction doesn't mean this force. Okay, torque are axial vectors, and angular acceleration are also axial vectors. Almost entirely anything that you deal in rotational dynamics are axial vectors. So torque in x direction is equals to x moment of inertia into angular acceleration in x direction. Okay, torque in y direction is equals to y moment of inertia into angular acceleration in y direction, and torque in z direction is equals to moment of inertia in zz axis or zz direction into angular acceleration in z direction. Okay, now can you find the difference and similarity between these two equations, this equation and this equation? Out here mass is a scalar quantity, so mass out here, mass would not change, you know, doesn't matter in x direction or y direction or z direction. But out here, while you're analyzing torque, okay, if you're analyzing the torque in x axis, okay, you have to take that axis, or you have to take the moment of inertia about x axis. That means if any body is there, okay, suppose this mass is there, this is a point mass here, okay, if you're analyzing moment of inertia about x axis, you have to consider this axis and find out the moment of inertia, okay, and that is the moment of inertia ixx. And torque about x axis would be moment of inertia about x axis into angular acceleration in x axis. Similarly, if you are finding out the torque in y direction, then you have to consider this axis and find out the moment of inertia of this particle along this axis. Okay, and then you can apply this formula. Similarly, when you are finding out the angular acceleration in z direction, or torque due to this direction, or torque in this direction, is equals to moment of inertia about the axis that passes through this point, okay, in this direction, into angular acceleration in this direction. That means whenever I'm considering my torque about origin O, that means my x-axis is nothing but this axis passing through point O or passing through origin. Y-axis is nothing but this axis passing through origin, and z-axis is nothing but this axis passing through origin. Understood? And a combination of these three becomes the net torque. Okay, is equals to moment of inertia into alpha. Whereas mass is very much simple. Mass is nothing but you take anywhere 5 kg, in x direction also 5 kg, in y direction also 5 kg, in z direction also 5 kg. But in case of moment of inertia, the moment of inertia about x direction could be different from moment of inertia about y direction, could be different from moment of inertia about z direction. Understood? So do not confuse about this part. Okay, understood? So suppose I'm taking moment of inertia about x direction. Moment of inertia about x direction is nothing but mass into r square, where r is the minimum distance from the axis. That means if I'm taking moment of inertia about this point mass, about this axis, okay, it is nothing but m into this much square, r square. Why this r square? Because this is the minimum distance from the x axis. Okay. Similarly, moment of inertia about y axis is nothing but m into this much r square. Okay. Why? Because this r is nothing but the minimum distance from y axis. Similarly, moment of inertia about z axis is nothing but m into r, because r is already the shortest distance between axis and point mass. Understood? So this is the fundamental confusion that most of you have, and this has been utilized again and again, okay, in your exam pattern, in this confusion. So let's go back to the simpler concept. In this question, okay, a thin uniform rod is there. Party of the question. A thin uniform rod is there. Okay. And if the axis is in z direction, Okay, axis is in z direction. That means axis is like this. The rod is can rotate like this. Okay, the rod can rotate like this. That means the rod is hinged at this point. Find out the moment of inertia about this axis. Okay, about this axis. So moment of inertia is nothing but mass of the rod is given as m, length of the rod is given as l. What is the formula for moment of inertia? I is equals to m into r square. So this is a continuous body. So you have the intuition that we must integrate it. So for integration, I take my element. Let the mass of this element be dx, or sorry, dm. Okay, dm. The length of this element is nothing but dx, or the thickness of this element is nothing but dx. So moment of inertia about this, or for this element, for this much amount of element, is nothing but this much amount of mass, this much or white amount of mass, into the distance of this white amount of mass from the axis, or into x. Okay, into x square. Understood this much? Moment of inertia is nothing but m into distance from the axis square. Now somewhere in this formula I have to convert dm in terms of x, or x in terms of dx. How do I do that? If the entire rod, if the entire length of the rod is L, and I'm considering the rod is made up of uniform density, the density of the rod is same throughout the rod. So density is equals to mass by volume, but in this case I'm talking about linear density. Okay, I'm not considering the volume of this. Linear density is equals to mass by length, which is equals to the density of this entire rod would be equals to the density of this white part, is equals to mass of the white part divided by length of the white part. And if I take this to equation, I'll get m by L into dx is equals to dm. And if I substitute this dm, okay, what do I get? Moment of inertia is equals to total mass divided by total length into dx into x square. Or moment of inertia is equals to m by L, which is a constant, into x square dx. I have to integrate this x square dx from 0 to length is equals to capital L, from 0 to L. So moment of inertia will be nothing but m by L into x cubed by 3 from 0 to L. Or moment of inertia is nothing but m L cube by, sorry, not m L cube, m L square divided by 3. So the moment of inertia of this rod about the axis passing through the side is nothing but m L square by 3. Okay. Now for the second part of the question. Okay, we have to find out the moment of inertia of a rectangular plate. The length of the rectangular plate is a. Okay, and the width is b. I have to find out the moment of inertia about this plate, about an axis that is perpendicular to the plate, or plane of plate. That means about this axis. And this axis must pass through any one of the vertices, either these vertices, or this vertex, or this vertex, or this vertex. Okay, so let's say my axis passes through this vertex. Okay, understood? What I'll use out here is perpendicular axis theorem. And perpendicular axis theorem are only applicable for planar bodies. Okay, perpendicular axis theorem. Perpendicular axis theorem. Only applicable for planar bodies. Only applicable for planar bodies or 2D bodies. Okay. What perpendicular axis theorem says is that moment of inertia about this axis is equals to moment of inertia about x axis plus moment of inertia about y axis. That means if I want to find out the moment of inertia about this axis or this z axis, I must find out the moment of inertia about this x axis. Okay, ixx, and find out the moment of inertia about this axis, iyy, and the moment of inertia about this axis or z axis would be moment of inertia about this axis xx plus moment of inertia about this axis iyy. Okay, so let me first take this axis ixx, or moment of inertia about x axis is nothing but m into b square by 3, m b square by 3, isn't it? Because at every point, isn't it, if I take this and consider this a long rod of length d, moment of inertia about this axis is nothing but m b square by 3. I've already derived in the previous part of the question, isn't it, out here? Okay, similarly moment of inertia about this axis is nothing but m a square by 3. So iyy is nothing but m a square by 3. So moment of inertia about z axis is nothing but mb square by 3 plus ma square by 3. Okay, so this is our question. Understood? That's it. You can also do it by another method. You can also do it by integration. Okay. Let's take an elemental integration out here. Okay. dm mass. But that is a very lengthy method, and I suggest you do not do it by that method. This is dm. Okay. Now that this dm is at distance r from the origin, isn't it? And moment of inertia over this axis is nothing but dm into r square, isn't it? Moment of inertia is nothing but dm into r square. Okay. Now r is made up of x square plus y square under root. This r is nothing but under root of x square plus y square, and r square is nothing but this square. So I is equals to dm into x square plus y square. Okay. Now I must consider this dm in terms of x and y. Okay. If mass of the entire plane is m, okay, then planar density is equals to mass divided by area, a into b. Okay, which is equals to elemental mass dm divided by dx into dy, isn't it? Understood? Planar density is equals to total mass divided by total area, which is equals to dm divided by area of this much amount of white surface, which is nothing but dx, or this much length, into dy, this much width. Okay, so if I consider these two equations, I'll get dm is equals to m by ab into dx dy. Okay, so I is equals to dm into, dm should be considered into am by ab into dx dy into x square plus y square. Okay, understood? Now this integration will be further classified. See, I is equals to am by ab into x square dx dy, okay, plus am by ab into y square dx dy. Okay, now see, first I must integrate entirety of x, then I must integrate entirety of y. See, out here x square dx is nothing but x cube by 3, and out here, okay, dy is nothing but the thickness of this much amount of element, no? So as I increase the value of x, the thickness will remain same of this element, isn't it? Is the thickness of this element decreasing or increasing? No, this dy would be considered while I'm integrating x, isn't it? So this is considered as constant. Okay, and out here this is nothing but y, okay, or dy. So I is equals to am by ab into dy x cube by 3 from how much? X is equals to 0 to x is equals to a, 0 to a. Okay, and this y, this thickness y, okay, should be from 0 to, this thickness y is same throughout, isn't it? Okay, plus am by ab. Similarly, if I apply same kind of equation out here, do nothing but dx into y cube by 3. Okay, I'll get my equation something like, let's take an empty space. M I is equals to m by ab dy, whatever this, dy into x cube by 3, dy into x cube by 3 from x cube by 3 plus m by ab into dx y cube by 3. The limits of x cube by 3 are nothing from 0 to a, and y cube is nothing from 0 to b. So out here 0 to a and 0 to b. So I is equals to m by ab into dy a cube by 3 plus m by ab into dx d cube by 3. Okay, now see, I also have to integrate this dy as it is going from this to this, isn't it? For 0 to x, suppose I integrated for this line, then I also have to integrate it for this line, no? I also have to integrate for this line, isn't it? So dy should be integrated from 0 to how much? 0 to b, 0 to b, and dx should be integrated from 0 to a. Okay, and I is nothing but m by ab into b a cube by 3 plus m by ab into a into b cube by 3. So b and q would get cancelled, a and a would get cancelled. After b and b would get cancelled, a and a cube would cancel to become 2. Or I is equals to m a square by 3 plus m b square by 3. See, if you have confusion about this method, you do not need to learn it right now. Okay, this is more about a computational method to find moment of inertia about complex shapes. Okay, how you integrate complex shapes inside a computer. This method. Okay, if you are in 11, 12 standard, just learn this method, perpendicular axis theorem. Okay, that is all you have to learn. This method is more for complex stuff. Suppose a complex integration comes up, okay, complex shapes comes up, and you have to find out moment of inertia. You cannot use pen and paper. That time you have to apply this method. Okay, this one. Then first you have to integrate it throughout the length. Okay, and the second step you have to integrate for the breadth. Understood? So this is our question. This is our question.